By other means, electron density mean type of bond. Type of bond, or by other means, how the atom of the mineral are bonded. How the atom of mineral are bonded. We have a three type of bond. Three type of bond between atoms. First one, I will show you a type of bond here. We have a three type of bond. We have a metallic in mineral. We deal with a mineral. We have a metallic bond. We have a covalent bond. And we have an ionic bond. So please take a look. We have a metallic bond. This is very, we have enough bond, many bonds in the structure. So it's very difficult for light to pass through this type of bond. Many bonds, many electrons. If we consider this is electron, we have a many electron density. Second, we have a covalent bond. We have a covalent bond. This is strong bond also. Strong bond, and it's made the light more slower as compared to ionic bond. Also, we have an ionic bond. We have just one ions. One anions control the strength on the bond, while the other ions not allowed to share this bond. So we want to know how these bonds affect the structure of mineral. So this is the velocity of light. Please take a look. Different velocity. And here we have a different bond. Here we have an ionic bond. This is big dog, and this is the other dog. So this bond is no stronger, or it permits the light to move easily between them. We have another type of bond. So this is same bond, covalent bond or diamond bond. So they more slow down the velocity of light. So first one is type of what? Type of bond that control what? The refractive index of mineral. Second factor, we have what? We have a chemical composition. Chemical composition. Please take a look here. Chemical composition. We have a crystal of what? Of olivine. We have a crystal of what? Of olivine. Here we have a relation between refractive index and what? And the concentration of ions. Here we have a Mg plus 2. The concentration in this corner for Mg is 100. Here is 0. And for Fe is opposite. Fe here is 100. Here is 0. You see, there is what? There is a positive correlation with increasing the amount of Fe, what? The refractive index increase. The refractive index of olivine mineral increase. So this is the effect of chemistry on the refractive index. By other means, the velocity. So here you see the velocity of light. The velocity of light in this portion is lower than the velocity of light in this portion. This is olivine mineral, and please take a look how this is FeMg. Fe enter the structure and Mg. Another example, we have a plagioclase. We have a sodic plagioclase and calcic plagioclase. Sodic plagioclase and calcic plagioclase. With increasing the amount of Ca and Al in the plagioclase structure, what? The refractive index increase, the velocity of light decrease. Refractive index increase, the velocity of light increase. So, how can we know this it's true or not? This is photomicrograph of olivine in two different type of rock. Two different type of rock. Here we have a dunite. Dunite is an ultramafic rocks in which the olivine are Mg rich. Here we have a gabbro. This is gabbro. It's intermediate rock, intermediate type of rock. Intermediate, I mean, it's contain more silica as compared to this type. If you look to the boundary of the grain and this boundary, here the boundary are more sharp. This is suggests that velocity of light is lower than in this area. So this is of high refractive index. This is of low refractive index. This is olivine. We have also plagioclase. I show you the diagram plagioclase. We have a two type of plagioclase. We have a Ca plagioclase, this white area. This is plagioclase in hornblendite, and we have a plagioclase in plagiogranite. Here, the refractive index is higher than in plagiogranite. Also, in this clear is not so clear, but here the refractive index are very sharp boundary. Here it's not so sharp the boundary. So this is suggests that the boundary is or the refractive index in hornblendite is more than that plagiogranite due to the composition of what? Due to the composition of plagioclase. Another important factor that control the velocity of light in mineral is crystal structure. Last lectures I talked about what? About kyanite, sillimanite, and andalusite structure. One of are tetrahedron, other are octahedral. So it is the same composition, but density of kyanite is higher than that density of andalusite and higher than that density of sillimanite. So the refractive index in kyanite, refractive index or velocity of light in kyanite is more than that in andalusite and more than that in sillimanite.